For handling message queuing and sending of messages between a producer and a consumer, or a publisher and a subscriber, RabbitMQ is a very important tool that can help you achieve that. So if you want to send data from a producer, which could be an application, right? And you want that data to be sent asynchronously, which is that it will be queued and sent one after the other to the subscriber or the consumer, another service or application. RabbitMQ helps you to do that. And how it works is that RabbitMQ has various exchanges, right, that your producer would send its message to. So you can have an exchange, various types of exchanges that your producer is sending messages to. And you also have queues. Now, when data is sent to the queue, it is stacked in a queue data structure, and the consumer reads from the top of the queue and processes them, does whatever operation it wants to. But data is sent and saved to the queue. The exchanges are bound to the queues through rules called bindings. So a binding connects a queue, an exchange to a queue, right? So when you send your data, it is received from at an exchange, and that exchange then knows how to route that data to the specific queue that it needs to go to based on the rule specified in the binding. And then the consumer reads from the queue. Okay. So there are various kinds of exchanges depending on how you want to send your data. There is a direct kind of exchange. And this is the most common kind of exchange you might find or you might use. It basically just sends the message to whatever queue is bound to that exchange, right? Whichever queue has a um, matching identity, it sends it there. There's also the fan out exchange. So you have the fan out. The fan out exchange is used when there are various queues, one to many. So your exchange, the fan out exchange, just broadcasts it to all the queues that are bound to that exchange. So you also have the topic exchange. In my experience, this is less commonly used. Basically, works with wildcards and can send the queue to whichever wildcard, or whichever queue. And then you have the header queue, which sends or routes messages. Header exchange, which routes messages based on headers attached to the messages. So this is how RabbitMQ works. And if you would like to try it out in your application, let me know in the comment section. I can maybe direct you on how to set it up in Kubernetes. A very important question that you might have is what's the difference, right, between RabbitMQ and Kafka? So I asked this question to myself many times. There are use cases where you would want to use Kafka over RabbitMQ, and I believe there might be some use cases where you would need RabbitMQ over Kafka. Although Kafka has some similar features to RabbitMQ, you can use Kafka for subscription and publishing, but it's mostly used when you need real-time log streaming kind of processes. And Kafka just gives you a producer and publisher and subscriber architecture, easily helping you to decouple two services, right? So if you want a simpler, more straightforward kind of, if that's what you're looking for, RabbitMQ is the way to go. If you need a more robust, highly available, real-time kind of streaming service, then you use Kafka. Okay, this is just publishing and subscription, and queuing basically. and asynchronous. It works asynchronously. So if you need real-time information, this offers you asynchronous data asynchronous message broker. So this is a message broker. This is a streaming solution. RabbitMQ, there are various alternatives to RabbitMQ. RabbitMQ works with the protocol MQTT, right? And some other messaging protocols, right? There are other applications that can do this for you. There's an application, it's a solution called ActiveMQ. I haven't worked with that one much, but I think it does message broking as well. There are managed solutions in whatever cloud platform you have, which is probably what a lot of people go with. I know people work with SNS a lot in AWS, which helps you to do this kind of queuing. On Azure, you have like Event Boss. But if you're working in a managed environment like Kubernetes, you might want to deploy your own message queuing solution. This can also message broken can also be handled by Redis, but RabbitMQ is pretty straightforward application built with Erlang, right? Pretty straightforward, pretty to the point, gets the job done, and easy to set up and manage. So there you have it, message broken at its finest. And I'll see you in the next one.